The major three effects of electric currents are something like this: the heat effect, the magnetic effect, and the chemical effect. When you see these coils out here, remember something: the amount of heat that is produced from these coils is actually dependent on the material of the coil, the thickness of the coil, and also the length of the coil. When there's an overflow of current through an electric circuit, generally what happens is that the appliances burn. So that's a damage, right? But again, this can be stopped, and this has been stopped all throughout. Wondering how? I'll show you. For a simple device like this. Yes, this is a fuse. And I'm sure you must have seen a wider version of this or some similar kind of version of this in your main electric circuit board. Right now also you can stop this video, go to your main electric circuit board, and you'll find this thing. Right? When there's an overflow of electric current, this thing burns. And it basically burns and it cuts the supply of electric current or the energy to the appliance, and thus that saves the appliance from getting burnt. How do you determine that they're genuine or not? That can only happen through an ISI mark. Yes, the ISI certification on all these gadgets or appliances determines whether they're actually good or bad quality things. And the ISI mark looks something like this. Look for this mark on all the electric gadgets. Once you find it, be rest assured about the fact that, okay, this is a good one and I'm gonna pick it up. Hey champ, welcome back. In the last video of this chapter, we're actually gonna talk about the magnetic effect of electric current. I gave you a brief about this in the last video, right? You remember it, right? Great. You know, while talking about magnetic effect of electric current, we need to understand about one small device, and that is the compass, right? This compass in itself is the one device that is known for pointing to different directions. One very important property of this compass is that the needle actually aligns itself in accordance to the Earth's magnetic field. For that reason, whenever it's kept inside a magnetic field, there's a deflection in this needle. Something like this. Can you see the deflection? Exactly. Now, you know, what I'm going to do is that I'll get back to you your most familiarized electric circuit. This one. You know, I'm going to switch it on and see. You remember this, right? Now, you know, one point that I'm trying to make is that when I switch on this electric circuit and there's a flow of electric current from the source through the switch to the bulb, there's a passage of electric current through this, right? Exactly. And now when I'm going to put a compass here near any of this wire, here, anywhere, okay, there's going to be a deflection. You can clearly see this deflection when the camera zooms in right now. Great. Can you see this? Absolutely. That is what I've been talking about. And this deflection in itself shows that yes, electric current creates a magnetic effect. Are you getting it? This in itself is a brilliant property of electric current. Now, aren't you wondering where is this property of electric current used? Think? Let me tell you, it's actually used in the concept of electromagnets. Now the question is, what is electromagnet? Electromagnet is that magnet which is actually formed by the passage of electric current, or you can say by passing of electric current through the whole thing. Suppose for an example, I talk about an iron nail, okay, and I pick the iron nail up and I pass electricity through it. That acts like a magnet. So that iron is now an electromagnet. As simple as that, right? Now I'm just gonna stop talking and I'm actually gonna show you how is that gonna happen. Okay, I have an iron nail here. Looks familiar? An iron nail? Yes. Now what I'm gonna do is that I'm gonna wrap an insulated wire around it. Something like this. You can see it. Now once that is done, I'm going to make it a part of a circuit. Now look at this very carefully. I have this set up. I'm going to detach these wires from this thing. Exactly, I'm going to keep it aside. And then I'm going to connect these two ends of the circuit to this thing. And I want to make it a bit tight. Connect it here, just like this. Exactly. Are you seeing this setup? Are you noticing this iron nail out here? I'm clearing the whole picture for you. Can you see this thing? Yes. Now, what I'm going to do is that okay, there was a small loose connection here. What I'm going to do is I'm going to wrap this up again so we can actually have this experiment properly. Okay. So now, as you can see, I have a complete electric circuit, something like this. Instead of a bulb, right now we have an iron nail which is wrapped around with an insulated wire, right? Now what I'm going to do is that I'm going to take some pins. Why I'm taking this, I'm going to tell you. What I'm going to do is take a few pins, keep it scattered like this. Can you see that? Yes. Now what's going to happen is that I'm going to switch on this whole thing. And now the electric current is going to pass through it. And what you're going to actually see is that, see, they're actually getting attracted to the iron nail. Can you see this? Exactly. Now, what happened is that we switched on the power current, we switched on the switch. The electric current just went across in the circuit, and it also went across the iron nail through the whole insulated wire. And that turned the iron nail to be an electromagnet. When it turned into an electromagnet, it had a magnetic field of its own. And that magnetic field attracted the small pins towards the iron nail. Now interestingly, what happens is that when I switched it off, okay, this iron nail lost its electromagnetic property and the pins again got scattered back. Are you seeing this? Exactly. This is the most interesting thing. The moment electric current passes through this iron nail, it becomes an electromagnet. The moment we switch the current off and it does not pass anymore, it does not act like an electromagnet anymore. Right? Talking about electromagnets, okay, they have got brilliant uses in our daily life. Let's talk about the speaker through which you listen music, or probably the speaker on a tablet or on a laptop through which you're listening me right now, or your headphones. They all use electromagnet. Again, doctors use electromagnets. For example, if accidentally we've got tiny pieces of magnet into our eyes, they use electromagnets to take them out. And all the toys that you played with, okay, the Hot Wheels or the robots or anything that you played with, you know, in our childhood days, they all used electromagnet. In fact, the doorbell also. It also uses electromagnet, and in fact, the electromagnet used in the electric bell is a masterpiece. I'm not going to talk about that in detail. I'm going to leave that to you. But again, all I wanted to tell you is that this is the magnetic effect of electric current, and electromagnets as such are used everywhere around us. And that is all for this particular chapter. I hope you learnt everything properly, and I want you to revise them again and again before you go for your chapter-based tests. Till then, have fun, score great marks, and I'll see you soon. Bye-bye. This compass in itself is the one device that is known for pointing to different directions. One very important property of this compass is that the needle actually aligns itself in accordance to the Earth's magnetic field. And this deflection in itself shows that yes, electric current creates a magnetic effect. What is electromagnet? Electromagnet is that magnet which is actually formed by the passage of electric current, or you can say by passing of electric current through the whole thing. Doctors use electromagnets. For example, if accidentally we've got tiny pieces of magnet into our eyes, they use electromagnets to take them out.